Thank you first for a so fast response. Okay, it's 9 o'clock. 36 students have already joined the class. So we'll wait for another 1 or 2 minutes. Let them join. Okay, Ganashri, thank you. Good morning to all of you. Hope yesterday's session was good. Hope you have enjoyed. Something you have learnt other than LIC, because not only the subject, a lot of other things you have to learn during engineering. Life will teach, but there will be pain when life is teaching. It is better to learn from the seniors and teachers and elders and parents. Otherwise, life will teach, but it takes a time and there will be a lot of pain. Good morning. We'll wait for a few more seconds, then we'll start the class. We are discussing filters and oscillator chapter. Let us continue the last bit of this particular chapter. Sample and hold circuit. Even I ask you people to write A to D converter, what input you are going to give, what output you are going to observe. Anybody want to write again? We have already spent a little time, but if you want you can try. I'll give 1 minute. Else again we'll continue the discussion. Thank you. Now, can you try A to D converter input and output? Somebody now try to write one line. I'll be happy to read your name from the chat box. Anyway, now this also we have discussed. Answer we'll get from there for that. Now this during a positive portion of a VS I am applying, and MOSFET conducts, drain and source will be short circuited. This is just for a revision. AB will be short circuited whenever it is high, and whenever I give 0, AB will be open circuited. Hope all these things you have studied. And gate inputs high and 0 I am giving. Because of that, whenever I am giving a high, so that time the drain and source will be shorted. Whenever I am giving 0, drain and source will be open circuited. Now I asked you people to copy down this in the last class. If you have completed, well and good. Otherwise, I will wait for a 1 minute. If you have completed, you just type done so that I can go to the next slide. Now this complete circuit is drawn by me only. I not copied from internet, but I took a lot of time to draw this. Now let us continue. It samples and holds the value till it samples again. What the circuit does is, MOSFET works as a switch. This basically works as a switch. And C acts as a storage element. And Vs, what you are applying, is a sample and hold control voltage. You can copy down and try to understand. Element. This acts as a switch, and this acts as a storage element. And this Vs, what I am applying, is a sample and hold control voltage. So let me go to the next. These are the waveforms. Wait, I will explain first. During positive portion, when I am giving the positive portion of a Vs, this plus if I am applying, MOSFET will conduct and drain and source will be short circuited. Hence, it is like a short circuited means whatever the input is there, it will come across the capacitor and it's a voltage follower. Whatever the input is there, I am giving to the non-inverting terminal, it will come as an output at the output pin. Now, simply output follows the input whenever MOSFET conducts. You can also carefully see here. Output follows the input. Output follows the input whenever MOSFET conducts, means whenever a Vs I am applying. Again, third also you can observe. Here also, whenever the signal Vs I am giving high, definitely capacitor will become voltage equal to input. The same thing I am getting as an output. So copy down this, take a 1 minute. Now we have discussed just now a positive portion of the Vs. Now we are going to discuss a negative portion of the Vs. What will happen in the negative portion of the Vs or 0 volts when I am applying? MOSFET do not conduct. These drain and source will be open circuit. That time output will be constant whatever the voltage is there across the capacitor. Observe carefully. See here. Whenever Vs is 0, that time output becomes constant. Output becomes constant. Output becomes constant. Observe carefully. So output will be constant whenever Vs is equal to 0. MOSFET do not conduct. So that time output will become a constant. So try to understand this. Take a minute and copy down this. When Vs equal to 0, MOSFET is off. C cannot discharge through the op amp because its input resistance is very high. Therefore, capacitor voltage will be held as it is. Ts is a sample period and Th is a hold period. Th is used for the A to D conversion. This chapter we are going to discuss in detail later. Now take a one line from this. Now I asked to write an input and an output. Anybody want to say anything? Again 1 minute I'll give you. When I give a 4 volts DC as a A to D converter as an input, output I may get 0s and 1 combination. For example, I may get 0 1 0 0 something like that. So this is what I asked in the previous class, and 2-3 classes I asked, even though videos are there in the YouTube, even though I asked you people to go through, only one student gone through because she believed me. Okay, so thank you. Let us go to the next. Copy down this at least now. So reference saying Gaikwad book and summary of this particular what you have taken, sample and hold circuit. Take a 1 minute, glance once again. Hope all of you have gone through the summary. This is a complete summary or a whatever you have discussed. We have discussed the zero crossing detector. We have discussed the schematic trigger. Points to be remembered while conducting the experiment we have discussed. And UTP, LTP, different if they ask what to do. Non-inverting schematic trigger. And these are the points what we have discussed so far. Schematic trigger, A to D, D to A converter we have to discuss. But peak detector we have completed, sample and hold circuit we have completed. Now we will try to discuss the specialized IC 305 timer and its stable mode, monostable mode we are going to discuss. One of the interesting topic, all these are A to D and D to A converters, your 305 timer, PLL are the very interesting topics. We will discuss those things now. Clippers were there earlier, now clippers are not there in the syllabus. But I have prepared a separate video on the clippers. I think it is more than 30 minutes video. And most of us, we think that we are good in clipper, only it will clip. But you go through the video, you'll come to know how much you know. Or at least if you know everything, it will become a revision for you. Now, a lot of experiments are there on this, and usually every year I used to give one assignment on this 555 timer. Compulsorily, students has to prepare a PCB, and any one 555 timer they have to application they have to show on the PCB after soldering in the working condition. But now I cannot give because of this pandemic. But hope those who are interested can do. It depends on you people. So 555 timer IC was first introduced around 1971 by the Signatic Corporation as a NE 555 or SC 555 and was called the IC time machine. During that time they called like that. And the 555 timer, there are many manufacturers are there. Company names are there. Fairchild is there, even National is there, Texas is there. Many companies are there. And their number are given, okay, like this, different names are given, and 8-pin T package is also available, and we have a 8-pin V package, but in our labs we use a 8-pin V package only, and these pin numbers you can note down from the next line. But remember, many companies are manufacturing, a small change will be there in the name. For example, NE 555, HA 555 and LC 555, like that, depends upon the name of the company. Some doubts will come why it's called a 555 only. If possible, we'll address that also. Some of the questions will be hanging in your mind. Answers you may get after some time. In lab, we are using any 555. Just remember that. And this is a pinout. And try to copy down the pinout. I'll give 1 minute for you to copy down. We want to do so many things, but we never do it. At that time only if you do, it will be easy. Now I want you people to remember the pins. We'll do it within few minutes. All of you close your notebooks. Don't say how you will come to know, sir. No, you should not bluff. I told, don't bluff a teacher, a doctor and a lawyer. I'm sure you people, you cannot tell lie to yourself. Okay. Now let us consider this pin number 2. Can you type pin number 2? 3 characters you can type. Not completely. What is the pin number 2? Okay, very good. And pin number 3. Very good. Pin number 3. 2 is coming now. I am asking 3 now. Very good. Rohit Shade, Preeti, Shreya, Muthu, Shreya, Shivam, Nishchal. Very good. Pin number 5. Pavan Gutti has typed. Ashish, Uluvesh, Siddharth has typed. Pin number 5 is a control voltage. Very good. Pin number 5 is a control voltage. Now pin number 7. Can you say pin number 7? Pavan, Usha, Manjunath, Sriranga, Ashish. Everybody has typed discharge. Correct. Shreya and Naina is typing pin number is a discharge. Very good. And pin number 4. Pin number 4. Anusha has told. Pin number 7. Very good. Pin number 4 is reset. Sri Harsha is typing reset. Okay, everybody is now typing a reset within a few seconds. Not a second. Within a second, so many have typed. Very good. Then any pin number 6. Pin number 6 discharge. Threshold. Very good. Pin number 6 threshold. Very good. Now let us do the reverse. Okay. What I will do, I will tell the what is the detail of the pin. You should tell the pin number. Hope that will be. Let us do the reverse operation. Okay. So now you can type the pin number for a output. Pin number for a output. Very good. Pin number for output is 3. Everybody has typed. Okay. Good. And what is the reset? Reset pin number. Okay, reset pin number. There is a small delay will be there between you people type and I get pin number 4. Very good. And now let us go to the next. I have to tell the number. Right? Discharge. What is the pin number? 7. Okay, 7. Good. And coming to the trigger pin number 2, correct. Okay, somebody told 6, thank you, but you have tried, Preeti. 6 is a 6 is what? Can you tell now? Others? 2 is definitely a trigger is a 2. 6 is what? Can you type? So that Preeti will remember it. Pin number 6. Threshold. Very good. See, everybody has become expert within 2-3 minutes. Okay. No need to say, I will do tomorrow, sir, day after tomorrow. At that instant, if you finish it, it will be very easy. And what is the VCC pin number? VCC 8. Very good. 8 is a VCC. So let us continue the discussion now. Hope all of you are remembering the pin numbers. Then let us go to the next. What are the prerequisites to understand a 3-5 timer? One should know the op-amp as a comparator, and one should know the transistor, flip-flop, resistor, divider network. This is more than enough to understand. Why to study? Because it is there in the syllabus. You will get some marks in the exam. That is usually what the students think. But even a lab, a lot of experiments are there on that. One should know. And being engineers, one should know this 3-5 timer, because a lot of hobby projects you can do. Even if you type in the Google 3-5 timer hobby project, lot of circuits will come in the website. You people can choose anyone. If you have a breadboard, you can do it in your room, and you can just show it to me. You can even send that video to me. I'll be happy to see that. Okay, and even I'll consider it for your CTA marks also. Anything you do, I'll consider for a CTA. Okay, so even if you do like a hobby project, this related to 3-5 timer, okay, even you can do the simulation also, at least in the beginning. Let us go to the next. These are the applications we have: monostable, astable, linear ramp generator, and pulse stretcher, pulse width modulator, pulse position modulator, missing pulse indicator, frequency divider, voltage regulator, and so on. And it is an 8-pin IC, works in 2 modes. One is astable mode and monostable, and usually supply voltage 4.5 to 18. Usually we give 5-6 volts in the lab whenever you are conducting the experiment. Take a 30 seconds, go through once. Now, hope all of you have gone through once. Some applications we are going to discuss in the syllabus. This is a basics for a 3-5 timer. I want all of you to type the answer. Say, what is the V reference voltage? Can you type now? The value of this is 10K, this is 10K, 12 volts I have given. What is the V reference voltage? Hope all of you know the voltage divider. And this question I asked in the offline class also. Again I am asking the same question in the online class. Very good, Shreya. Thank you for your answer. Most of the students, they are typing Pooja, Manjunath. It is a 6 volts. Why it is 6 volts? Total is 12. All of you have seen now. So total is 12. So this is 10K, this is 10K, divided by 2, this will become 6 volts. So this I have given a 6 volts. Now there is no feedback. It's an open loop. When open loop is there, I have connected here LED. So LED will glow whenever this becomes plus Vset or minus Vset. LED will glow whenever this V out becomes plus Vset or minus Vset. I am repeating the question. V out is plus Vset or minus Vset when a LED should glow. LED will conduct in forward bias. So it should be plus Vsat, because whenever it is a plus Vsat, it's nothing but you are applying a plus voltage here, and this will conduct and LED will glow. Very good, all of you. Now I am asking you the 2 questions. I want you people to type. So VI I am applying 2 volts. This I am applying 2 volts. Whether the LED will glow or no. You can say glow or not glow, or yes or no. The question is VI equal to 2 volts. This I am giving 2 volts. Whether this will glow or not. No, sir. Okay. Somebody is telling thank you. For both answers, thank you, because you are thinking and you are telling something, whatever is there in your mind. Okay, majority are telling. Anybody is okay. Somebody is saying 2 volts it will glow, sir. Somebody is saying no. Try to understand. Open loop. Whenever this is 2 volts, okay. This is how much? 6 volts. Whether inverting is more or non-inverting is more. So okay, this is more. So this will become plus Vsat or minus Vsat. So when this becomes plus Vsat, whether it will conduct or not. Now, consider second case. Vi equal to 8 volts. This I am giving you the 8 volts. Now, whether the LED will glow or no. You can say yes or no. I want this time same answer from all of you. Okay. Let me see. Somebody is saying yes sir or not. Okay. Pooja is telling yes sir. Very good. Whatever she is understanding, she is sharing. I appreciate. This is a 8 volt Pooja, positive. This is 6 volts. Which is more? This is more. And you are applying plus. This is inverting. When this is inverting, this will become plus Vsat or minus Vsat Pooja. This voltage is more. Means nothing I have applied, extra I have applied here. Some positive voltage. When this is positive voltage Pooja, this output will be plus Vsat or minus Vsat. You can type Pooja at least in the chat box. So this is some voltage. This is nothing, or this is 6 and this is 8. This is more. When I am applying more voltage here, positive, this is a positive, this is inverting, output will become minus Vsat or plus Vsat. Open loop op amp is very simple. If a inverting voltage is ज़्यादा है तो, yeah, plus Vsat you are telling. If it is an inverting terminal and plus voltage I am giving, whether it will become plus Vsat or minus Vsat. Now I want you people to type when Vi is equal to 8 volts, whether LED will glow or not. Okay, they are telling no. Good. Majority are telling no. Here and there if somebody is telling again yes, no, we have to have a discussion again. Okay. Now let us go to the next then. This is no need to copy. Hope all of you can understand. No need to copy. If you want, I can wait for another 30 seconds. Otherwise, anyway, one more circuit is there. There I will wait. So now, I am asking you the question. What is the voltage at K or V reference? It is the same 6 volts only. Vi equal to 2 volts, whether LED will glow or not. I repeat the question. Vi equal to 2 volts. It is a 6 volts. It is a 2 volt. 6 is more. And it is a positive, whether it will glow or not. Very good. Many students with confidence they are typing without taking a time. No sir, no sir, no sir. Even Pooja Kotabagi has typed. I am so happy to see now her answer. Pooja Kalyanmat has typed because they had a little doubt. Now if I give, say Vi equal to 8 volts, whether LED will glow or not. I am giving 8 volts here. It was a 6 volts. Vi equal to 8 volts. Now LED will glow or not. And majority are saying, sir, LED will glow. Yeah. This fundamental, this basics if you know of the op amp, then understanding a 555 timer is not at all difficult. It will become very easy. Now I'll give a minute for you people to just go through because of this polarity change. So how this LED blinking will change, try to understand. When the output of this will become high. Pin number 2 below the 1/3. Very good. Rohit Shet is typing the answer. Sir, op amp output will become high, second op amp, when the trigger becomes less than 1/3 VCC, and many are typing. Pavan Gutti, Vinayak Damodar, Uluvesh, Rohit Shet I have to appreciate because they have typed so fast. And Vinayak Damodar, Anusha Paschapu, Sita, everybody is typing. So hope all of you understood now. Coming to the next. When op amp 1 output will be high. When this will become high. When pin number 6, next you have to tell. And this is trigger is correct. Okay, all of you are typing a trigger. I want this. Now how much it should be, above, below, so that this should become high. And a threshold becomes greater than 2/3 VCC. Ulvesh is typing and Shreya is typed. Very good, Shreya and Ulvesh. When it becomes greater than 2/3 VCC, because this becomes more, when this is more, automatically this becomes high. So this output is given to the set of the flip-flop. This output is given to the reset pin of the flip-flop. So most of them, they are typing pin number 6 greater than 2/3 VCC. Sita, Rakshita, Kulkarni, Preeti, many are typing the same. And let us go to the next. These are the basic fundamental one should know to understand a complete 555 timer. And this is also completely drawn by me only. I took a lot of time to draw all these things my own. Understand this. Hope all of you understood. And let me go to the next. This is a block diagram. This you can copy down. This I copied from internet. You can copy down this. And most of the students in the exam, even now also you observe, this is short circuited. There is a connection. There is a connection. I don't know, some students will put dot here also, they lose 100% marks. Here there is a connection, here there is a connection, and there is no connection here. Most of the students, they will put 4 dots here, 1, 2, 3, 4 in the exam, they lose 100% marks. Now only I am telling you. And this is NPN or PNP, observe carefully. This is NPN, PNP, observe carefully. They interchange sometimes, or sometimes they will make both NPN or they make both PNP. So they lose complete marks, because if something goes wrong in this, it will never work as a 555 timer. So inverting is connected here. This side non-inverting is connected. You can use one resistor. First you can draw this much, beginning only, so that nothing will go wrong. Otherwise in the exam, I am observing students will interchange these two polarities or these two polarities, or they will short this and they take this outside. So it looks very simple, but most of the students do a lot of mistakes in the exam. Recall these pins just once again. Take a 30 seconds. Recall these pins. So just tell twice, thrice in your mind so that you'll remember all the pin numbers. Okay. Now, what is the pin number 1? Pin number 1, can you type in the chat box? Answer. Ground. Okay. Pin number 5. Pin number 5. Vinayak Damodar has typed. Rohit Shet has typed. Pin number 5. Forgot already. Just now you have discussed. What's the pin number 5? Write down in your notebook once again all the pin numbers. Pin number 2, trigger. Pin number 3, output. Pin number 4. Write down these in your notebook once again. And pin number 5, correct. All of you have told the answer. Control voltage. That may be delay in what you are typing. When I'm getting. Everybody typed control voltage, but due to network I got all the answers now. Thank you, all of you. And pin number 6, threshold. Pin number 7, discharge. Pin number 8, VCC. Just go through these things. Try to remember. And we'll conclude a class today. Its time is over. Pinout we will discuss in the next class. What's the trigger, output, in brief we'll discuss. Then circuit diagram when we discuss, we'll become more expert in this, how each pin works. And we'll conclude today's class. Take care. Bye. Have a good day. And I'll be here for another 5 minutes. If you have any doubts, you can discuss with me. Take care. Bye. You can leave the class now. Thank you.